Here's an important question. We have this liquid of water in a jar which is accelerating in the right direction with an acceleration a. We need to find out the difference in pressures at P2 and P1, and we also need to find out this angle of inclination of this water surface, that is theta. So for solving this question, we first let us try to find out theta. So for solving this question, this angle is theta, this is P2, this is P1 at a distance L. We take a cylinder of water again and we hope to apply Newton's law on this cylinder of water that we have taken. The pressure at this point is P2, this point was P1, this point is P2. Let the pressure at this point be P dash 2 and the pressure at this point be P dash 1. Now P dash 2, that is the pressure at P2, can be written as this height be h1 and let this height be h2. Since there is no turbulence in the system in the vertical direction, therefore vertical direction's equations do not change, and therefore we can write the pressure at point P2 to be equal to P naught plus, that is the atmospheric pressure, plus rho g h2. Similarly, the pressure at P1, that is P dash 1, can be written as P naught plus rho g h1. For this water body, we will let the surface area of this surface be equal to A. Therefore, we write Newton's law in the horizontal direction on this cylinder of water to get P2 into A, P2 dash into A minus P1 dash into A is equal to mass of this cylinder into acceleration. This was length L. Therefore, rho into A into L is the mass of this cylinder of water. This is a cylinder of water, imaginary cylinder of water which we have assumed to apply Newton's law on this system. Mass into acceleration A in the right direction. On solving this, we get P2 dash minus P1 dash is equal to rho into A into L. So the difference in pressures in these 2 points P2 and P1 comes out to be rho A into L. Now substituting the values of P2 dash and P1 dash from here, we get P naught plus rho g h2 minus P naught plus rho g h1, that is rho g h2 minus h1 is equal to rho into A into L. We cancel the rho to get g into h2 minus h1 upon L is equal to A. Now this was h2, this was h1, so h2 minus h1 is this is h2 minus h1, this is L, so h2 minus h1 upon L, this angle was theta, therefore this angle is again theta, therefore h2 minus h1 upon L is equal to tan theta, therefore we get g tan theta is equal to A, rather tan theta is equal to A by G, that is theta is equal to tan inverse A by G. So our final answer for the angle theta made by this surface of water is equal to tan inverse A by G, and the difference in pressures at these 2 points is equal to rho A L. From this question you should learn many things. The first thing being that the pressure at the same horizontal level is not always the same. It is only the same when the acceleration in the horizontal direction is 0. Since in this question this body of water had an acceleration in the horizontal direction, therefore the pressure at the same horizontal level will not be the same. This is another method in which you could have solved this question. Let me tell you that also. It is difficult to strike, but once you know it, you can use it in the future. Let us solve the question relative to this jar. Since this jar is an accelerating reference frame, let us apply Newton's law on this particle of water at the surface. This experiences a force mg downwards, this particle of water, and it also experiences a pseudo force in the left direction. Now the acceleration of this point mass of water along the surface has to be 0. Since this object, this particle of water, is not moving along the surface. Therefore, the acceleration of this particle along the surface should be 0. Therefore, the component of mg in this direction comes out to be mg sine theta, and the component of ma in that direction comes out to be ma cos theta. This is in this direction. So, if forget these two, the other two components come in the perpendicular direction, which may be balanced by other forces. So, along the surface the net force is mg sine theta minus ma cos theta. Now, relative to the jar, this particle is not moving along the surface. Therefore, the acceleration of this particle along the surface is 0. Therefore, we get this as 0. Therefore, mg sine theta is equal to ma cos theta. So, we get again tan theta is equal to a by g, that is theta is equal to tan inverse a by g. This is an alternate method to find out theta, that is tan inverse a by g. After finding out this, you may also see that, let me show you another thing, that this angle was theta, mg was acting in this direction, ma was acting in this direction. Both these forces are constant. The resultant comes in this direction. Let this angle be alpha. Therefore, tan alpha can be written as mg upon ma, that is equal to g upon a, that is equal to 1 upon tan theta, as we had already found out the value of tan theta to be a by g. Therefore, tan alpha is equal to cot theta. Therefore, alpha is equal to pi by 2 minus theta. Now, this angle was theta. This is pi by 2 minus theta. Therefore, this angle is pi by 2. So, what we come to know from this question also is that the resultant of the gravitational force and the pseudo force comes out to be in a direction perpendicular to the surface, or rather we can say that the surface arranges itself perpendicular to the resultant of ma and mg. So, now in this perpendicular direction, the pressures at this level all will be same, because if we know g to be in this direction, a was in that direction, so the pseudo force came in this direction. So, we always find out g effective. G effective was equal to root over g square plus a square, and its direction is found out in this fashion. So, the g effective came out in a direction perpendicular to the surface, and its value is equal to root over g square plus a square. So, we can now apply the old formulas like this. In a direction perpendicular to the surface, if we move a height h from here, or a height h from here, or a height h from here, that is at the level which is at a parallel distance of h from the surface, the pressure at all of these points will be same, because when we apply the equation in the frame of the jar, the pressure comes out to be same at all these points. So, final answer was P2 minus P1 was equal to rho AL. Therefore, there is a difference in pressures of rho AL which is needed to provide the necessary acceleration to this block of water, and the tan theta was equal to a by g, that is theta is equal to tan inverse a by g. These two are our final answers.